everyone. Good afternoon. Sekarang ni ada 121 orang. Sekejap I'll admit a few more. Yang lain tu nanti Syauki tolong admitkan ya. Anyway, so welcome to our second AE clinic. We have Dr. Sharifah Muzlia here who is going to explain about chapter 4 and 5. So I hope everyone will take note about what she's going to deliver because you need to finish your AE this semester as soon as possible, kan? Alright. Without further ado, I think I will pass the video to Dr. Sharifah Muzlia, and maybe we can start with Al-Fatiha first. Alright, Dr. Sharifah Muzlia, the mic is yours.
Okay, thank you very much. Before I forget, let me record this. Session. Okay, I'm recording. Right. And we sedekahkan the Al-Fatihah to a few of our staff and your friends who are affected by COVID-19. Yeah, hopefully everybody will get well soon and the rest of us will not be infected and things will go back to normal. Okay, thank you very much for joining us today. Can you hear me well? Okay. Right, and now you can see my slide. Yeah.
We can see your slide.
Okay, thank you. Right, I want to jump straight into the talk because I have only given myself 2 hours, but actually I can go on for 3 or 4 hours, but I'm sure you cannot listen to more than 2 hours, yeah, especially today is about statistics and qualitative analysis. So we will talk about the importance of matching your research objective with data analysis, yeah. So the content of this talk is, first I will give a little bit of a pep talk, yeah, and then we will talk about, I will remind you the outline of research report, regardless of your being undergraduate or master or PhD, the outline of chapter 1, 2, 3, 4, 5 are about the same. And then we will go into the data analysis, quantitative and qualitative. Okay, let's talk first. Yeah, this clinic is called Academic Exercise Clinic 2. Yeah, for your information, students, master and PhD, there are a few here. This academic exercise is for the undergraduate level. Code EDU 650. It is the final year project. So they are doing research also, and they are at the beginners level. Yeah. So for them, yeah, for all of you final semester students, if you want to graduate at the end of this semester, my question is, of course, how is your progress in research? This is week 8, yeah, and you have 7 more weeks to submit your final AE. Yeah? Your final research is due on the 16th of July. So I counted that is 7 weeks more. Be aware of this date. This is the date, the week when you must submit all completed chapters to your supervisors. Okay. So where are you now? Yeah, in the attendance form, I have given the like a survey. Yeah, where you are now? Are you refining your chapters 1 to 3? That is good. Yeah. Have you collected data, or are you in the process of collecting data? Yeah, which is also okay. Yeah, if you are collecting your data now, it's okay. If you have not started, I will give you a red light, yeah, a yellow lah, yeah, yellow light, because you are in the critical time period. You should be collecting your data around these weeks, yeah. But because later you want to analyze your data and you want to write your chapters 4 and 5, yeah, and you have only 7 more weeks to go. So push yourself, yeah, and go ahead and collect your data quickly. And a question I should not ask, but it is often sometimes neglected by students. Yeah, you are working on your own for whatever reasons. You cannot contact your supervisor, or you contact your supervisor, but he or she has not replied back, blah, blah, blah. Yeah. So whatever it is, my reminder is you need to work well with your supervisor and make sure that she or he is in the know of what you are doing. Yeah. So say if your supervisor has not replied to you, you just continue to WhatsApp her, text her or him, yeah, and inform him or her that you are doing this or that because you are rushing for time to target for submission. If you do not push him or her at the same time, you stop working. Later, you will be in trouble, yeah, because you cannot complete it in time, yeah. So whatever issue or problem you have in relation to completing your data, please, yeah, you can either talk to your supervisor, you can talk to the coordinator. Here with AE, you can talk to Dr. Farhana, you can talk to me as advisor. Yeah, I call myself advisor lah. Yeah, self-promoted, self-appointed. Sorry. And anything with statistical analysis, feel free to text me, yeah, anytime. You can share your data. You can ask me how to do this and that. I will, inshallah, uh, reply to you. Yeah. Okay. Now, outline of chapters. Yeah. Okay. Please switch off your mic. Yeah. Unless you want to ask me something. Shauki, please switch off. You have to scroll down the participants list and see who are not muting their mic. Yeah, thank you, Shauki. All right. Chapters in the academic exercise. Yeah. So last the clinic one. Dr. Hamimah have talked about chapter 1, chapter 2, and chapter 3. So now I am focusing on chapter 4. Yeah, I will talk about how to analyze your data. Yeah, I admit that I will be focusing more on the statistical analysis. If you are doing it, fine. If you are not, maybe you can just sit back and relax. Yeah, and just get knowledge about what kind of analysis to do for certain types of data and research questions. And later we'll talk about chapter 5 discussion. Okay, so this is standard outline. You can save this for your thesis writing or dissertation or project paper. Now, how to write chapter 4? Yeah, basically, when we talk about our data, yeah, the chapter will begin with 4.1, a short paragraph, yeah, on what will happen in this chapter, and then you can explain about your demographic or your respondents, yeah, 4.2 demographic findings, and you always start with your table or a graph, yeah, on who are your respondents, how many respondents, how many male and females, yeah, if you have what more, the, the where they are from or what kind of a background they have, yeah, whatever you have from your questionnaire maybe, yeah, you can put a table that describe your data underneath. And then 4.3, you start with your research questions, yeah. So copy paste Okay, this is a basic step. Yeah, don't rewrite your research questions. Yeah, copy paste from chapter 1 to chapter 4. Why? Because then you will not have the tendency to rephrase, yeah, paraphrase and make changes to important variables in your research question or research objective. You think it's nice to have a similar verb or similar noun, yeah. This is not creative writing, yeah. This is technical writing. So just copy paste saja, yeah, from research question 1 and then research question 2 and then research question 3, and you can turn this into a subtitle. Yeah, you can leave it as research question or you can turn your research questions into a subtitle. And then for each research question, what you do is again, you have a table of your result, your graph, or if you are doing qualitative, your transcription. Yeah. And then underneath the table or the transcription, you make a 1 or 2 paragraph here to describe your data. Then you interpret your data. Yeah. So the process is like that. Yeah. How many how many research questions you have, you can repeat them 1, 2, 3. And finally, you have conclusion here. Okay. Right. So now let's do the matching research objective with analysis. We will start with quantitative data analysis. Yeah? Quantitative data analysis, as you know, it is all about numbers. Yeah? These are for people who are who collected their data using survey or questionnaire. Yeah, or you have numbers from documents or data record from the school or whatever. Yeah. So it's quantitative analysis, and the most important thing is to know what type of statistic to use with what type of discussion and research objective and the type of data. Then I will talk about how to enter data in your SPSS. Yeah, it's just a demo. Yeah, because we don't have time to go through the actual SPSS workshop that would require another 1 or 2 days workshop. So I will just brief through, but inshallah, all the notes in my slides here will be helpful to you. You can practice, yeah, using your own, during your own time with your own data, and the steps is all explained in these slides. Okay. So let's look at this table, yeah. Quantitative design, matching purpose of analysis with your research objective. What are your research questions? And then your type of data and the statistical analysis. Okay. Now, I will give the few examples here. Yeah, the main purposes of study normally used for undergraduate researchers. Yeah, so for master and PhD, if you think this is too basic, sorry. Yeah, but it is enough for the undergraduate level. Yeah, okay. For example, if you want to describe something, you are doing just description, yeah, of your data. Okay, and your research objective is like to determine the same motivation level of students in learning something. And here I'm just giving example of genetics, a topic in science, yeah, because the science students say genetics is one of the most difficult topic. Okay, so you want to know the motivation level of students in learning genetics, and you have a set of questions in your questionnaire to ask about the motivation level of students in learning genetics, right? So you, as I teach in class, or for those who have gone through, who have been in my classes or my workshop, yeah, you just copy, yeah, this objective and paste to your research question, and turn the statement. Objective is in the form of statement, turn it into a form of question. So to determine the motivation level of students in learning genetics can be as simple as what is the motivation level of students in learning genetics. Okay. Now, if you want to compare, okay, for example, you want to compare between two groups. Two groups meaning, for example, for your variable, you want to compare the performance level between gender. Yeah, and gender we have male and female students. So this is called two groups. Yeah, one group is male, two group is female. So when you want to compare between two groups, yeah, statistically, the right way to write your research question is again copy, paste to your research question and write something like, is there any significant difference in the performance level? See, yeah, the word is the same. In the performance level between gender, or you can say between male and female students. Yeah? But if you want to compare 3 or more groups, yeah, for example, you want to compare performance, but instead of gender, race, and race you have what? Malay, Malaysia, yeah? Chinese, and Indians. So 3 groups or more, yeah? Or you want to compare between classes A, B, C, can do also, yeah? So you transform that into your research question. Is there any significant difference in the performance among the 3 races? Okay, so the purpose of this study is comparative study. It's called comparative analysis, right? Now, we will talk about data and statistical analysis, yeah, in a minute. Okay. Because this is type of data. Okay. Now, if you want to okay, next one, yeah, you still want to compare, okay, but you want to do before and after. Yeah, I'm sure you are familiar with pre and post. Yeah, pre and post test. For example, you want to compare the performance or the motivation level or whatever before and after something. Yeah? I've talked about how most appropriate for you educational researchers to try and teach something new, yeah, a teaching approach, or talk about a learning style in the among students, yeah, for students or for teachers. So you have an intervention, yeah, and you want to see how effective, yeah, is the intervention. So before the intervention, you give a pre-test, yeah? And then you give the treatment here. Yeah? And then after the treatment, you give the post-test, right? So the research question is there any significant difference in the test score before and after the intervention? Okay. Now for this purpose, yeah, your data would be the pre and post test. Okay, and the pre and post test, it can be a test of understanding, for example, say quiz on science, yeah, before doing mind mapping, yeah, you give a quiz on science, then you give a treatment of mind mapping techniques, and then after mind mapping techniques, you give post test of the same quiz and see if there is any increase. Now, because you are studying the same person, yeah. So, for example, Ani, yeah, will have pre-test, and Ani will also have post-test. So, the same person have 2 scores, yeah, pre and post. So, this is called a pair of scores. That's why you will be using paired sample t-test. Paired sample t-test, because every respondent will have a pair of scores, pre and post. Now, unlike the previous one, compare between two groups, male and female. Now, male and female, are they the same individuals? No, right? So the males are males, the females are females. So they are not the same individuals. They are different groups. They are independent of each other. That's why the t-test is called independent samples t-test. Similarly, if you are studying comparing races, races are also independent of each other. There are three different groups. It can be three different classes. So you cannot use paired sample. You use t-test, but since it is more than three groups, t-test is upgraded to ANOVA. Okay, so two groups, independent sample t-test. More than two groups, 3 or 4 or 5, you use ANOVA. Okay, but if it is pre and post, you use paired sample. Okay, backtrack sikit. If it is descriptive, you just want to describe, for example, what is the motivation level? Okay, before that, sorry. For example, you just want to ask motivation. Are you motivated? And you say yes or no. So yes or no, is called nominal data. I will talk about this in a minute, but this is just introduction. Okay, yes and no is nominal data, and if you want to describe that, the best statistic to use is frequency level. Frequency is how many, for example, how many say yes? 58 people. How many say no? Only 10 people. And from this, you turn it into percentage. How many percent? 58 out of 68. How many percent? And then 10% is how many percent of 68. So that is how you describe a nominal or ordinal data. But if your data is in the interval or ratio form, for example, when you have questionnaire, what is your motivation level, and you have 5 questions on a rating scale, where people circle, from 1 to 5, circle, and you get the mean score, you sum it all and you get the mean score. Say you get 4.68, on a rating scale from 1 to 5, and that is a high motivation. So anytime you have a decimal point, this is called basically interval and ratio data, and the best statistics to use is mean and standard deviation. So this is mean, the friend is standard deviation. For frequency, this is frequency, and the friend is percentage. Dalam Melayu ni kawan dia, kawan dia frequency, best friend dia percentage. Mean, the best friend is standard deviation. So you just need to describe these two statistics, right? So that is descriptive. Then comparative, remember, independent samples, t-test, 2 groups, ANOVA, more than 2 groups, right? And pre and post test, paired sample t-test. Okay, at least get familiar with the name of the statistics. All right. Next, if you want to do relationship, you want to find a relationship between two variables x and y. Okay, And the conceptual framework, the arrow is double-headed, yeah, and this is the independent variable, this is the dependent variable. So for example, you want to find if there is any relationship between motivation and academic performance, yeah. So you want to find relationship between motivation and academic performance. Okay, and how do you measure motivation? Is there any research question? Is there any significant relationship between motivation and test score? So motivation are measured by your survey. So you get a total mean score here. Yeah? And performance is measured by a test score, yeah, or the quiz or the midterm exam or the final examination is up to you. Yeah, you decide. So it's a score of 0 to 100 lah. Yeah. So everybody get a score of 0 to 100. So you relate between the two. Yeah. So this kind of data is called interval and ratio, and we will talk about Pearson correlation analysis. And the most suitable statistic to use is Pearson correlation because your data is interval and ratio. But if your data is nominal or ordinal, yeah, so instead of motivation, a mean score, you measure motivation by a rank, yeah, a rank of low, moderate, high. So this is ordinal turned into, this is nominal turned into ordinal. What is nominal? Nominal is categorical. Yeah, nominal macam yes and no tadi, ya, male or female, that is nominal. But you have an order like low, moderate, high, yeah, A, B, C. So your test score, instead of score, you have grade A, B, C, E. Yeah. So that is an order. A is basically higher than D. High is basically higher than low. So that is an order. So it's called ordinal. Now, if you relate between these two kind of data, nominal and ordinal or ordinal and ordinal, then for relationship, you use what's called cross tabulation and chi-square. Yeah, but if your data is mean and mean, yeah, this is mean actually, the score is 78.8, yeah, that is decimal point. Mean score and mean score, interval or ratio, then you use Pearson correlation. So that's why it is important for you to understand what kind of data you have, yeah, because then you will use the appropriate statistic. If not, it is considered wrong. Now, last but not least, for today, we will learn a prediction. If you want to predict something, yeah, for your purpose of research, for example, you want to examine if motivation can predict performance. Okay, most of you, I hope, have known the main difference between relationship and prediction. Yeah, relationship is just where you want to relate between X and Y, but you are not saying X causes Y. Yeah, but with prediction, you can say X causes Y, and the arrow is one-headed. Yeah, you can say the independent variable is causing the change in dependent variable. That is regression. Yeah, we use regression. So here we are saying, can motivation influence performance? Can motivation predict performance? Can motivation cause performance? So these words you can use, yeah. So motivation can predict performance. Yeah. So this is a simple conceptual framework. Notice the arrow, one arrow here. Yeah, this one is two double-headed arrow. Transform to research question. Simply, does motivation have any significant effect on test score? Or can motivation affect test score? Or does motivation predict test score or predict performance? Yeah, simple words for prediction. And again, you have interval and ratio data like this. Yeah, mean with mean, you can use regression for regression. Okay, right. Now, if you have any question, pressing matters you want to ask throughout my talk, you can just on your mic and ask. Yeah, if not, you can just type in the chat box and later I can answer it. All right. So I hope you get the flow of the importance, yeah, of knowing first of writing a good objective with the matching research question. Remember, do not use different words, paraphrase or whatever. Simply copy, paste, transform from statement to question. Yeah? And then determine what type of data you have. And then you can determine what kind of statistics you will use. Okay, so you can create a table here, yeah, like this for your chapter 3, yeah, and the data analysis or research questions. All right, now I am going to the heavy part of the afternoon, yeah, using SPSS. Okay, uh, most of you maybe are familiar with SPSS, yeah, or have heard about it, right? So SPSS looks like this. Yeah, you can install it if you know anybody who has. Yeah, pirated, or you can download the student version. Yeah, for a free trial of 2 weeks, I think. Yeah, so you don't have much time to analyze your data. Make sure you have your data set, and then you enter your data and analyze your data quickly. But if you are able to get the permanent software somehow, somewhere, yeah, do so. Okay. Now, before we go to the data entry, let's talk about the questionnaire. Yeah. So this is a simple example. Again, I want to highlight the types of data. Yeah. So what you have here is for example, a questionnaire on motivation to learn genetics or whatever lah, English or whatever. Yeah. So you have question 1, question 2, question 3 for your demographic here. Always have a few questions for your demographics. You might not use it later, yeah, but it is always compulsory to describe who are your respondents. Yeah, so you better have a few questions. Think about what is good to describe who are your respondents in terms of gender, in terms of age, yeah, in terms of background, family background, or maybe SES if it is relevant to your study lah. Yeah. So gender, male or female, interest, a low, moderate or high interest in the subject, and test score, we leave it blank. And then you have a set of 5 items, yeah, to measure motivation. The topic is motivation. So for your questionnaire, you have 5 items to measure motivation. Okay, so what are these, yeah, in relation to types of data? Okay, now, when you want to enter data to the SPSS, the questions become your variables. Yeah, so just label your question as question 1, question 2, question 3. That is most easy. Or you can label your question based on the keywords, yeah, gender, interest, test score, that becomes your variables. But you can simply put the question number. That is more easy for you when you want to trace back, especially if you have long list of questions. Yeah, go by go by apa section, right? Part, yeah. Part B, yeah. This is part A. So it's easier for you to search your data later. And then you have the answer to your questions. Yeah? Gender, male or female. These are called values. Okay, your answers are called values. And the values for SPSS, yeah, you can leave it as male or female, meaning you type the word male or female. In that case, that will become, that is called string. The string is alphabet, characters. So name of students, if you have name of students, for example, yeah, or you want to type male or female, that is called type of data string. But normally we transform the values into numbers. Yeah, so you just put in the box number 1 for male if the student is male, number 2 if the student is female. Yeah, if he or she take moderate, then for interest you key in number 2. Yeah, if the student take low, then you key in the number 1. All right, so the values are turned into numbers. Okay, and these values are called, just now I explained, yeah, nominal data. Why? Because it's categorical. Yeah, male and female is a category. Male, not female. Female, not male. So it's either or. It's nominal data. But if the nominal data is ranked, you have a sense of ranking. For example, low, moderate, high. Yeah, so ada low, moderate, high. There is some sort of order. So this is called ordinal data. All right. Next one, test score. Yeah, test score when you put a range of numbers, yeah, or you ask the respondents to fill in the numbers. Yeah. And anytime you have decimal point, that is most easiest to say it is interval or ratio. Yeah. And in statistic class, you will talk about real zero, true zero, or arbitrary zero. Yeah, zero means, true zero means zero have meaning. So for test score, for example, zero has meaning? Yes, because 0 marks means you don't have any marks, zero. Yeah, but in some cases, zero have no meaning. For example, weight. Yeah, you cannot have 0 weight. You cannot have 0 height. Yeah, but with score, you can have true zero. With temperature, for example, you can have 0 Celsius. That means very cold, right? Yeah, so this is true zero. So this is ratio. Yeah, ratio. I am always confused with. This is ratio data. And the next one here, the items here with the rating scale 1, 2, 3, 4, 5. Yeah, it starts with as nominal data. Yeah, strongly agree, disagree, neutral, agree, strongly agree. This is nominal data, either or. But when you transform to numbers, yeah, and plus you compute later, yeah, for example, this students rate everything as 4, 4, 4, or 5, and 5, yeah. So you will have a total mean. Okay, 4 plus 4 plus 4 plus 5 plus 5, yeah, divided by 5 items, yeah, you will have the total mean. The total mean comes out to, for example, 4.68 just now. Yeah, so 4.68, and this is interval data, yeah, because it's based from the interval of 1, 2, 3, 4. Okay, so you need to know what type of data you have because you want to know which statistic is best to use. Okay, right. So we are ready to enter our data. Yeah. So when you on your SPSS, you will get this window. Yeah. And make sure it appears with all the headings here. Yeah. If the heading only have file and edit and no more here, that means your software will not run properly. It will not analyze data. Yeah, either it's pirated or it's not downloaded properly and so on. Yeah, so make sure when you have downloaded and you open it, it will have all this. All right. So to cut short, yeah, because we don't have time to really show step by step, but I will just explain to you. Now, when you open the data, when it's open, yeah, you notice there are two view here. One is called data view at the bottom left. Yeah. The other one is called variable view. Okay. So first you want to go to variable view to set up your code book. Yeah. In the old days, we don't have the software. We have books manually, so it's called the code book, where you set up all the variables. And later, after you finish this, then only you go to data view to key in your data. Yeah, so now let's go first to variable view. All right, here. Yeah. So in variable view, you are now in variable view. You will see this step is called defining the variables. Yeah. Once you type in the name of the variables, this is the name of variables. Your job is to type in, yeah, based on, remember the questionnaire that I showed you just now, yeah. You just type in Q1, Q2, Q3 for question 1, question 2, question 3, yeah. And this is from part B, and this is for question 3, and so on. Okay. Now, when you type one variable, the rest of this will automatically appear. Yeah. So for numeric, yeah, this is type of data. Automatically it will appear numeric. Numeric stands for numbers. So you want to key in numbers, so it's okay to leave it like this. In case you want to type in name of your respondents, yeah, for some reason you need to have names for your respondents, then you click, there is 3 dots here. Yeah, I can't show it here because it's not live. It will appear like this, yeah, 3 dots. Okay. Click on the 3 dots, yeah. The options will be there, numeric, string, dates, currency, and so on. So if you want to type numbers or address, for example, yeah, you choose strings. And automatically it will change here string, yeah, for example, string. And instead of values 1, 2, 3, you will type in the name. Yeah, class A, class B, class C. Right? So that is string. But you don't want to use string, so let's remain with numbers. All right. That is type of data. A width is just for appearance sake. Yeah. Decimal points. Okay, decimal points meaning, do you want your data to appear with decimal or not? Yeah. For example, when you say gender, remember, we say gender 1 is for male, 2 is for female, right? Yeah, gender 1 is male, 2 is female. Do you want to appear? Do you want it to appear as 1 and 2, or you want to have 1.00 as male and 2.00 as female? Nice, right? Yeah, so you just want round number 1 and 2. Yeah. So this is without decimal. So again, you want to click on the 3 dot here, yeah, and make this 0, 0. If you want decimal, for example, for test score, remember we want to put a decimal point, yeah, for the marks. That is okay. Then you put 1 here. If not, you just turn everything to 0. Okay, decimal point. Next one, label. Yeah, label is a description of your variable. If you are lazy, you don't need to write anything here. And whatever comes out in the analysis or print out, the name of variable will come out. Q1 relate to Q2. Yeah. But if you don't remember what is Q1, that is maybe the disadvantage lah. Yeah. If you have many list of questions. Yeah. But if you want it to appear nice, then you type the label for your question. So instead of it coming out as Q1, yeah, gender will come out. Yeah, we will look at the example of output later. So you can type in gender, Q2 is class, that's one, yeah. And for this questionnaire items, you can just copy paste. So you don't have to type again. Yeah, you can just copy paste from your document file, and you can highlight the rows here, and then you can paste it, and it will automatically go to these boxes. Okay, very easy. Right, that is label. Yeah. Values. Yeah, values is again the answer to your questions, male or female. Yeah. So click on the 3 dot, yeah, and you will see one, you will type in 1 for male and 2 for female. Yeah, in a minute I will show you that step. And the rest of this you don't have to change. Yeah, missing is okay, leave it blank. So when you have missing data, everybody knows what is missing data. When your respondents don't write anything, yeah, so you just leave it blank. Yeah, so the SPSS will read it as missing. Columns aligned, no need to change anything. So there you have your variable view. You are done. Now you are ready to enter your data. Yeah. So how do you enter your data? See, you will see all your variable names will appear here. Yeah, Q1, Q2, Q3, yeah, dash. And whatever data you can start with, 1 until 23, this is the respondents. Yeah, so respondent 1, his or her data is this way, the first row. Yeah, right. So for question 1, is he male or female? Male. Yeah. From what class? Class A. Yeah. And test score, I think this is test score. Yeah. So the test score is 70.5. Yeah, see, this is the decimal point where we put 1. Yeah, if we don't put, if we put 0, it will appear like this, no decimal point. Yeah, and this is the rating scale. So you shall key in all your data, questionnaire by questionnaire. Yeah, make sure after 5 or 10 rows you save and save and save, yeah, especially if you have hundreds of data, you don't want to cry if suddenly the electricity went out, yeah, and your data went out, yeah, before you can save it. So always save your data. You can go to file, save as. Okay, all right. So when you are done with your enter data, you are ready to analyze your data. But wait, yeah, wait. Make sure your data is clean. What is clean means you have not made any mistakes when you key in your data. Yeah? And how do we know we have not made any mistake? For example, instead of entering 1, 2, 3, 4, 5 here, suddenly you enter here number 6. Yeah, because of error or your finger is tired or whatever. Yeah, or you enter here 0. There is no 0 on the scale 1, 2, 3, 4, 5. Yeah? And after hundreds of data, you cannot see all these numbers. So what you need to do is do the cleaning process first. Yeah. So how do you clean your data? Simply by doing frequency analysis. Yeah. So here is the first experience for you to analyze your data. Yeah. I'm sorry if this is too small for you. So maybe later you can make it bigger and have a look. Yeah. So the step 1 is you go to analyze, yeah, and then descriptive statistics, and click on frequencies, and this window will appear. Yeah. There are 2 boxes. The left boxes have all your variables listed.
Is this advertisement?
And then on the right variables, the empty ones is where you choose whatever variable you want to analyze. So for this cleaning data, you want to analyze all variables. So what you do is you click one and you campak here. You throw in this box. Yeah. Click another one and throw it here. Or you can do it quickly. You Control Shift, yeah, and highlight everything. Click on the arrow and everything goes here. This is what happened. Yeah. So you have all your variables on the right box. Then display frequency tables and click OK. What happened? You will get the frequency tables like this. Yeah. So list of frequency tables based on what you have asked. Yeah, this is your table of content. Yeah, if you have like 100 questions, items, it will all list. Yeah. So what you do now is you scroll down the page and check each table to see if there is any incorrect data. If there is, go back to the data and find the incorrect location and make the correction. After all data has been ensured correct, then you save this data file, then only you analyze your file. Yeah. So what happened is you just scroll down and see gender table, male, female, nice. Yeah. Male, female, frequency percent. A class, Intan, Brilliant, Zamrud. Okay, no weird figures. You want to look out for weird figures. Yeah. Test 1, 30, 32, 47. Yeah. Say if you remember your test, your respondents, how come there is this number 30? I don't remember students being this weak or low. Yeah, so you just want to double check. Go back to the data. Yeah, for example, here you go back to your data. Yeah, and you scroll down these numbers and see where is that 30. Okay, for example, 30 is here. For example, so 30 is for respondents number 23. So what you do is you go to your questionnaire number 23 and see, is it correct that his or her performance is for test is 30? Yeah, or is it you have mistakenly entered the wrong numbers? Okay. So if it's true, then okay lah. If not, then maybe you want to change. Oh, it's not 30, it's 50. Yeah. So if it's 50, so you correct it here and then you save, file save here. Yeah. So that's what meant by checking every table to make sure your data is clean. Yeah. So here I don't have examples of error because every table looks fine. So what does it mean when you have only somewhat agree and agree? Not all four, yeah? Somewhat agree, strongly disagree, and strongly disagree. It's not here. What? That means nobody answered strongly disagree or disagree. Yeah, everybody just answers somewhat agree and agree. So no problem here. Save this data file and you are ready to start analyzing. Okay. Are you still okay out there?
Yes, Doctor.
Yes, yes.
Yes, Doctor.
Yes, Doctor.
Yes. Yes,
Okay, thank you
Doctor.
so much. Yeah.
Yes,
Feel free.
very clear.
Okay, feel free to eat your kuih raya. Okay. I will proceed with analyzing data. So here comes the statistics. Okay. First, yeah, demographic details. Yeah, as I said, every chapter 4 need a section on demographic details where you describe your participants. Yeah, participants. So make sure if you have not collected your data, yeah, or in the process, make sure you have questions on background of your respondents. So you just want to describe your participants, yeah, in terms of gender, for example, yeah, or you can make it a research question. For example, to determine number of respondents based on gender, class, race, level of knowledge, or blah blah blah. Yeah. So basically, this is not research question lah. Yeah. I just give you an example. You want to know how many students in each group, and the purpose is just to describe, and it is just nominal or ordinal data. Yeah. So the right statistic to use is frequency. The friend is percentage. So the step is similarly to cleaning data just now, yeah. Analyze descriptive statistics, frequencies, and then this box will appear. So instead of taking all the variables, you just want to analyze gender, how many gender. So you click gender was here, yeah. So you click on gender, you click on the arrow, and gender will be in this box. Okay, make sure the display frequency table is on, tick, yeah, and then you can just click OK. So what happened? You will get this kind of output in the second, yeah, without blinking your eyes. The output is ready for you, yeah, in terms of gender. How many male are there in the study? We have 32 male, percentage 47.1%. Yeah. Female 36, percentage 52.9%. Right? So what happened then? You can start writing. Yeah. You can start writing your demographic. You copy paste this table to your chapter 4 and transform your table SPSS. Yeah. You don't want this kind of table. Transform it into APA format. This is APA format, yeah. Everybody, education should use APA format, yeah. No borders, just header and what's called this, the lower part. No need all the borders here. So you copy the output and paste it to your chapter. And if you remember the outline just now, yeah, a table and then a description. So you just describe referring, yeah, to the table, label your table, shows the distribution of gender, and then repeat the numbers in the table. A total of 32 or 47.1%, yeah, of the students are male, while another 36 in bracket 52.9%, yeah, are females. Yeah, so see, remember the best friend, yeah, frequency, best friend, percent. So you just make sure both of the friends are in your sentence. Okay? So no need to explain why gender is more or less here and there, because your purpose is just to describe. And no need interpretation or descriptive. Okay? Or instead of a dry or boring table, you can turn it into a pie chart, yeah, or whatever chart. Okay, the guideline is only if you have table, do not have chart. If you have chart, do not have table for one data. Yeah, so meaning for one data, you only present one figure. Yeah, don't put both figure. That shows you have not learned anything from the workshop. Yeah, so you can use like this lah. Yeah, so for gender you use table, but for class you use pie chart just to make it more interesting. Okay, so you have a pie chart and you label it right. With table, the name is on the top of the table. With diagram and figure, the name is underneath the figure or diagram. Yeah, that is also the formatting. Yeah, and then again, same structure of writing. Yeah, mention the name of the figure or table, and then describe the numbers, frequency. The best friend is percentage. No need to explain. Got it? Okay. Right. Next one. Yeah. This. Right. Just now it's nominal or ordinal data. What if your data is interval or ratio? Yeah. Remember, we want to determine performance test score. Yeah. And performance is in terms of numbers. Yeah? So this is called ratio data. So it's not suitable to use frequency and percentage. Okay? Instead, you want to use mean and standard deviation. And if you are describing performance in terms of tests, yeah, normally you can talk about the range of the test from minimum performance to maximum performance and so on. Yeah, so you can use this descriptive. Yeah, the type of analysis is called descriptive. Yeah, so the step is here, analyze descriptive statistics. Instead of frequencies, you use descriptive. Yeah, descriptive statistics, descriptive. And this table will appear. Yeah, the title is descriptive. And you click on test and throw it in this box. So test, yeah, test performance here. And you click on options. Okay, options, this box will turn up. Okay, now options give you options of whatever descriptive you want the computer or software to give you. Yeah, so you can pick all, yeah, if you know what it all means. Yeah, but for describing test performance, for example, yeah, you can just click on the mean of the test, standard deviation, the minimum score, the maximum score. Yeah, the range, yeah, and the variance. Okay, so that is the normal thing lah. Then you click continue. In a second, you will get this output. Yeah, this output. Okay, this table. This is from SPSS. Yeah, where it says test one. N refers to what? N refers to the number of respondents, number of data you key in. That means you have 68 students. Yeah. Okay, the range. What is range? Range is when you minus, yeah, maximum from minimum. So high score minus low score. Yeah, so 82 minus 30 here, you get 52. So the range of marks in your class range from lowest 30 to highest 82. Is that good or bad? Then you want to say variance, yeah, and you want to say standard deviation, but that is in another class. Yeah. Main thing you want to see, what is the average performance of students in this class? So it is 62. Yeah. So 62 means good, bad. Yeah, it depends on your subject, right? So if your students are good students, average of 62 is quite low. Yeah, but these students, 82, score highest, then she is above average. But these students, 30, she is very weak, right? But if you are teaching a class of the last class, for example, where performance are weak, but suddenly the mean score is 62, you might want to jump with joy, because somehow your students perform much better, So whatever interpretation, you need to go back to your real world, And then you transform, copy, paste, your table from SPSS to APA style, and it becomes like this, very clean, neat, And again, title of table, the table, and then the description. Now, how to write the description? I will tell you, share with you the secret. A simple 5 steps to write the description. You have all the ingredients for a good result writing. So 1, you state the purpose of analysis. Students were given a pre-test to determine their level of mastery in the topic before attending the motivation talk. So this is purpose of your study. This is the the purpose of your study lah. Name the type of statistical analysis. So it can be seen, descriptive statistics, descriptive analysis is used, So just now, remember, we use descriptive statistics. Number 3, refer to the name of the table. So as shown in table 4.2, your name of table, you must refer to the table. And then step number 4, you highlight the important numbers from the table. So the challenge is to know what are the numbers to highlight. So I'm giving you all the guidelines in these slides. So for mean and standard deviation, as I said, mean, the best friend is standard deviation, just 2 numbers. So you can say something like, on average, students have moderate performance because the mean is 62 points, blah, blah. Standard deviation is 12. You don't need to explain standard deviation, but it is the best friend, so you just state them. But maybe if you are from mathematics, or this is really like master of PhD level, you want to explain standard deviation. And then the minimum and maximum score you can interpret as the weakest student achieve only 30, minimum score, and the best student scored highest 82. The range of 52 between lowest and highest test. Right? So you just describe the numbers, and then only you interpret in short the numbers. Something like this results indicates that although there are a few students who achieve high scores, many more are in the middle and lower level. So you have all these ingredients, 5 ingredients, you have a paragraph there, and you get your result writing. If you are good with writing, you can elaborate more lah, but basically this paragraph is enough to describe this table. So you have the description of descriptive statistics. Okay, if your data is items in the survey, so same thing, as I said just now, you want to, you have data from question 1, 2, 3, 4, 5, and it's all like Scala, right? So you want to, and remember the students rate 4, 4, 4, and then 5, then 5. So what you do is you total sum, total, and you get the mean score. And that data is interval ratio. So you also use mean and standard deviation. So the question is how to get the total mean score. So the step is the same. Analyze descriptive statistics, descriptive. Now here when you get this box, yeah, you now, okay, this is the trick, yeah. You want your questions to appear like this. Q 3A, Q 3B, but you don't remember what is this questions, right? Yeah. So this one is called display variable names, yeah. So if you click display variable names, it will appear like this. So if you want to change, you just click on your mouse, right click, yeah, on this, you highlight and right click, these choices will appear, and you say display variable labels, and your items label will appear. If not, your variable names will appear. So it's up to you, yeah, which is more easier for your eyes. So most important, if you highlight all these 5 items and click it and put in this box, it will become like this, right? Yeah. And then remember, you click on options. Okay, click on options. Yeah, sorry. Yeah, click on options. And for this, you just want mean and standard deviation. No need all this minimum, maximum. That is for test performance. Yeah, this is just for rating scale. You just want the mean and standard deviation. You click continue and you click OK. This is the output. Yeah, in a second, it will appear your list of items, question 1, question 2, question 3, question 4, question 5, and 68, meaning 68 respondents. This is the mean, best friend, standard deviation. So I enjoy this topic, 3.56. How do you interpret this 3.56? Out of what? Out of the scale. Yeah? So the scale is 1 to 5. 3.56 is about, yeah, right. Yeah. So this is about moderate, somewhat agree, middle range. Yeah. Again, standard deviation, the smaller, the better. Yeah. Smaller is like less than 2. Yeah. Standard deviation less than 2 is good. If it's too large, that means your respondents answer too varied. Too varied. Okay. So you copy paste this table. And you have a nice output here. Yeah, research question. What is the level of motivation students have in learning genetics? Yeah. Name of table. Transform your table from SPSS to APA format. Yeah. And you just have mean and standard deviation. And you write your 5 ingredients of writing. Yeah. See? It has the purpose, number 1. It has what type of analysis used, descriptive analysis. Yeah? And then it has the result, numbers, mean, best friend, standard deviation. Yeah? How many times you want to say it for each item. Yeah? If you have many items like 20, you don't want to repeat all 20 items. Maybe you just take the highest 3 and the lowest 3. It's up to your supervisor how he or she want it. Yeah. And you finish with some interpretation. Yeah, the lowest or the highest rating. Okay, so this is descriptive. All right. Okay. I think I'm going to go quickly more, and I have to skip a few bonus steps, yeah, because there are many more statistics to talk about. So if you want to categorize scores into different categories, yeah, for example, from test score range, you want to turn it into a category of weak, average, high. Yeah, you can do that. You study this slide. Yeah, I I'm afraid I don't have the time to go over it. It's called recode, yeah, recode step. Okay, and I also have here bonus step of how to create that nice charts or a bar chart, yeah, using Microsoft Word. Yeah, instead of SPSS will produce you the charts, but the charts is large and not user friendly. But if you use a chart from insert and here, yeah, charts here, yeah, they have many more options and easier to use. Yeah, so you can look at this slide. Yeah, it's very easy to use and it produce nice charts like this one. Yeah, and you can choose all types of design. Yeah, from above the document text. Then okay, right. I need to go to the next statistics. Yeah, comparison. Remember, comparison has two types, yeah, independent sample t-test or paired sample t-test. Okay, independent sample t-test is when you want to compare performance between how many groups? Two groups. Okay, two groups, yeah, and compare between two groups, and your data must be interval or ratio form. Yeah, basically meaning standard deviation. So performance and gender. Okay, so your your you want to test the difference between performance. So performance is the test score, yeah, between two groups, male and female. Okay, so the step is analyze. Okay. Compare means, and then it has a list here. Yeah, one sample means independent, paired sample, ANOVA. So you want to click on independent sample t-test, yeah, for two independent groups. Then it will, this box will appear. Yeah, again you choose carefully. There are two boxes here. Yeah, one is called test variable. The other one is grouping variable. So grouping refers to the group. So you want to compare what group? Gender, right? Yeah. So you click on gender and put here. Yeah. So Q1 here is gender. If you remember that. Yeah. So gender, click here. And whatever thing you want to compare, in this case performance, yeah, you click on the upper box. So test one, yeah, which is Q3 here, and grouping variable Q1 here. And then it has question mark. Yeah, it is asking who are your group. So what you need to do is define group. You click on define group, this box will appear. Yeah, and you just type in your number. Group 1 is 1. Don't type the word. Yeah, don't type the word. Just type the number. Yeah, the value. 1. Group 2 is 2. Now, why is it asking? Yeah, stupid. The software. No. Yeah. For example, you have class, right? So class, you have 3 classes. Okay, you should use ANOVA, but for whatever reason, for this paper, for example, you just want to compare class A and B. You don't want to use class C. Yeah? So when you put compare groups Q2, yeah, so you can type in class 1 and class 2. Yeah? Or if you want to compare class 1 and class 3, so that's where you compare only 2 groups of your choice. Yeah? So for gender, it looks like a weird step, but if you have more than 2 groups, then you appreciate this step. Yeah. So continue, and then you click OK. Yeah, go back to here and click OK, and you get this output. independent sample t-test. Right, yeah. Right. Okay. So this is the table that you will get, two tables. Yeah? One is called group statistics, yeah, where test one, yeah, male there are 32 males, and female there are 36 female, yeah, and the mean for male is 64. Test score, the mean for test one for male is 64, for female is 61. So from your eyes, yeah, observing who has higher marks, male or female? Male, right? So male students have higher marks, yeah. But with inferential statistics or with higher statistics, you cannot depend on just raw numbers. Yes, that is wrong. Okay, you want to use the significant test, yeah, to see if really this number 64 is truly significantly higher than 61 given the number of respondents, given the standard deviation, given the standard error mean, whatever that means. Yeah, I'm not too comfortable explaining that because I am not actually from the statistic background. Yeah, but I can explain by this time. But you want to be sure, yeah, that 64 is significantly higher than 61. So that's why you do the independent sample t-test. Yeah, and you need to read three numbers. This is p-value. This is the number you want. This is DF. DF stands for degree of freedom. In final year students, you have taken this in your SPSS class, right? During your semester 6. So this is a review. Yeah. And significance test, yeah, two-tail. Okay. Now, first, with t-test, independent, you want to, first step, yeah, look at Levin's test. Yeah, Levin's test is called Levin's for equality of variance because it wants to say whether your two groups, male and female here, have equal variance or not equal variance. Equal variance, remember variance from the word vary, yeah, vary. So equal variance means both male and female groups, their performance are closely together. So equal variance, yeah. So they are of this at the same par. So if that is the case, you will look at this first line, equal variance. But if your two groups, yeah, are not equal variance, yeah, you let the computer calculate for you, yeah. Not equal variance, meaning male are originally performing higher than female, maybe, yeah, or the variance of responses are, not regular, then you want to read the second set of data. So how do you do this? Look at Levin's test. If not significant, read the first line of t-test. If significant, read the second line of t-test. What is significant and not significant? Significant test, yeah. P-value, probability value. Okay, to cut it short, yeah. It's less than 0.05, meaning from 100% confidence level. You cannot get 100% confidence level in social science. So normally, people experts put it at 95% confidence level. When you are confident at 95%, meaning how many percent you are not confident? 100 minus 95? 5%, not confidence. Yeah? So not confidence here, this is called the margin error. confidence level, and you turn it into 95%, 5%, sorry, 5% margin error, turn it into decimal point, 5/100, you will get 0.05. So that is the cut-off point to say you are confident that 95% of your respondents answered truthfully, honestly, correctly, blah, blah, blah. And you only allow 5% due to error, whatever error, not feeling healthy that day, not being honest, error of questionnaire and so on. So 0.01. And then another numbers is 99%. So that is quite high, meaning you only allow 1% margin error, and that comes up to 0.01. So these two numbers are normally used as significant p-value test, 0.01 or 0.05, but normally we use 0.05. So anything less than 0.05, it is significant. Anything more than 0.05, it is not significant. So back here, if Levin's test is not significant, meaning Levin's test is larger than 0.05, then you read the first line. So where is significant? Levin's test is, F is Levin's test. Significance is 0.355. So 0.355 less than or more than 0.05. Anybody from the audience? Dengar sikit suara?
More.
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 Okay, more, So more than 0.05, that means it's not significant. Levin's test is not significant. Therefore, you read the first line of the test, meaning the equal variance is assumed. So you read this output. This output. So this output, the value is 0.954. Degree of freedom is 66. Significance is 0.344. If, for example, significance of Levin's test is say 0.023, which is less than 0.05, therefore it is significant, then you read the output of the second line. So you read this line, which is basically not too different also. It's still not significant here. Okay, but just know which line to read is important, for independent sample t-test. All right, so now we are taking these values to write in our analysis. Okay, so for t-test, I don't think they have APA's format. You can copy paste the original SPSS output. Is allowed. So you copy paste both. And you interpret. The writing using the 5 steps. State the purpose. Okay. You want to compare whether male and female students differ in their achievement test. Okay. And then you state the statistic. Independent sample t-test was conducted. Then you state the result. So the result, referring to table, remember, it was found that 3 results. You need to put the p-value, degree of freedom, and the significance of the first line, remember? So the p-value is 0.954 here. Degree of freedom is 66. Degree of freedom you cut short is your n. N, remember, your n sample is 68 minus groups. 2 groups. Sorry, K is for group, 2 groups. So 68 minus 66, you got, 68 minus 2, you got 66. Okay. But the most important thing is to look at the significant test. So same guideline, significance, if it's larger than 0.05, it is not significant. So this is 0.344. is larger than 0.05. So the interpretation is this result indicates that there is no significant difference in the test score between gender or between male and female. Therefore, interpret, in other words, male and female students have similar level of performance. No significant difference, meaning they are the same. And are they the same at what level? If you remember, the average is like 62, yeah? So 64, 61 is about the same, yeah? No one is exactly, male are not significantly better than female in this case. See, wrong judgment if we use only descriptive compared to if we use t-test, yeah? Higher statistics called, sorry, I forgot to talk about that, yeah? It's called inferential statistics. Compared to lower level, is called just descriptive. Okay. Right. Next one. More than 3 groups. Okay. If you want to compare performance between, ouch, this is not more than 3 groups. Yeah, sorry. This is between what? Race. Yeah. Class. Yeah. Sorry. Class, not between class, among class. Among 3 classes. Yeah. And is there any significant difference in the performance among different classes? Among the 3 classes? Among students in the 3 classes. And your data is again test score. So you use ANOVA. As I said earlier, ANOVA is the sister to t-test. Yeah, it's just because you have more than 2 groups. It's repeating t-test actually, yes. The basic is t-test. Okay. So you shouldn't be, it shouldn't be difficult for you here. So the step is analyze, compare means, yeah, because you want to compare the means of the 3 classes. And here, just now independent sample, now it's one way ANOVA, yeah, analysis of variance ANOVA. So then you get this box, yeah. You have 2 boxes, yeah, like independent sample t-test, but instead of grouping, remember, and it has question mark just now, for ANOVA, it just put factor here, and you don't have to define, yeah, it will take whatever groups you have, 3 or 4 or 5 or 10, yeah, it will compare for you. So it's called factor, yeah, put in your group here, and then put in your dependent variable in this box. Okay, and then click on options. Okay, this box will come out, and you want to click on descriptive. Yeah, you can not click descriptive, but then you will not have the mean and standard deviation output. So please click on a descriptive, then continue, then go back. Okay, so you will get this out. Yeah, ANOVA output, also 2 table. Yeah. So this is the descriptive, yeah, that if you don't click just now, it will not appear. Rugi lah, yeah. So it's a waste. So click descriptive, you will get the descriptive, the means for each class. Intan, Berlian, Zamrud, yeah. The different respondents here, 21, 25, 23, total 68 students. Yeah. And the mean shows who has the highest performance? Intan with 75 marks, followed by Berlian 59 and Zamrud 53. Okay, and the standard deviation here. And even have minimum maximum here, yeah. So your if the question which group has highest mean, based on your eye view, you say Intan, yeah. So class A has the highest mean, yay, yeah. Good for you because class A is supposed to have highest marks lah, yeah. followed by Berlian, followed by Zamrud. But your question is there any significant difference, true significant difference between these numbers? You want to do significant test, right? So you look at the second table, ANOVA, and you look at the p-value, again, significant test. Yeah, so where is the significant test? This one. Yeah, p-value, significant test boleh, p-value boleh, yeah. Sometimes it's called alpha. Yeah, same person here. Okay. This F, capital F, that is the ANOVA value. Yeah. And df is the degree of freedom. Okay, so degree of freedom here is 68 minus 68 is from N68 tadi. Sorry, 65 comes from N68 minus number of groups 3. So you got 65. Yeah. Degree of freedom group, number of groups minus 1. So number of groups got 3 minus 1 got 2. Yeah. So you don't have to find it, you just take the numbers here. ANOVA value, yeah, is here. Most importantly is p-value. See what is the numbers. If it's less than 0.05, it's significant. If it's more, it's not significant. So this one, significant or not? Anybody?
Significant.
Significant. Sure. Okay, yeah. Right, correct. So it's significant, you want to jump with joy. Yeah, significant. I find significant test. What if you find not significant result? Will you cry? Will your research be wasted? No, yeah, don't cry. It's not wasted. It is still a finding. Yeah. So of course you are a little bit depressed because it's not as expected. Yeah. But due to some reason, yeah, your respondents' results found there is no significant difference. You just need to explain or find reasons why in this particular data respondents it is not as hypothesized. Yeah. You don't need to collect any more data. Just find reasons for your non-significant result. Okay. So then, another step. If ANOVA is significant. Now, if ANOVA is not significant, yeah, if it's not significant here, you stop analysis here. Yeah, the finding is there is no significant difference among the 3 groups. But if ANOVA is significant, there is another test called post hoc test that you need to do. Yeah, because the question next is, which of the 3 groups is truly significant? Yeah, you want to give more detail. Is it between Intan and Berlian? Or is it between Berlian and Zamrud? Or is it between Intan and Zamrud? Yeah, you want to compare the pair. Yeah, so you have to do what's called post hoc test. So how to do that? Yeah, you just do the same step for ANOVA just now. Yeah, put your test 1 here, class here, and you instead and options. Remember descriptive. And next one, you click post hoc. Yeah, when you click post hoc, this window will appear, and there are many types of post hoc tests. Yeah? So for PhD students or master by research, you need to know which one is suitable. But most often, the LSD or Bonferroni is used. Yeah? Okay, significant level is set at 0.05. Then you continue, and you will get this output. Yeah. So just now the descriptive output and then the ANOVA table significant plus the post hoc test. This is the post hoc test. Yeah. So you compare means the question is which group is truly different from each other. So it will compare pairwise. Yeah. Intan with Berlian, Intan with Zamrud. Berlian with Intan, Berlian with Zamrud. Zamrud with Intan, Zamrud with Berlian. Yeah, and every pair it will minus mean difference. Minus Intan from Berlian mean. Yeah, and it will get the mean difference here and the significance. Again, just look at the significant output. If it is less than 0.05, meaning there is true difference between this group and this group. So you can jump with joy. All groups are truly different. Yeah? And you can also look at the asterisk here. Yeah? The asterisk means the mean difference is significant. Yeah, so this is just to double confirm. This is the indicator given. Yeah? So even meaning even with Intan and Zamrud and Berlian just now, who has a small difference of this one, yeah? This one 75 and 59, way different. But 59 and 53 only of 5 points, Berlian and Zamrud. Yeah? It is still significantly different. Berlian and Zamrud. Berlian and Zamrud. Zamrud and Berlian. Same thing, yeah? It's repeating. So, same numbers. 6.75. 6.75, yeah, minus because it minus Zamrud from Berlian. This one, it minus Berlian from Zamrud. Yeah? So, the same numbers. And it is still significant. So, you get more detail for your result that you can write. I don't put it in the nice way. Yeah. So there you go. Okay. So you use the 5 steps to writing analysis and write under your table. Okay. Right. So that is comparing more than 2 groups. Yeah. 3 more statistics and then I'm done. Pet sample. Okay, pet sample is when you want to compare performance before and after. Yeah, before and after treatment or intervention, right? Yeah. So your question, is there any significant difference in students' performance after attending the motivation talk? For example, so you compare means before and after, and your data performance is interval or ratio. Yeah. So you use ouch, this is not ANOVA, sorry. This is pet sample. I've gone through this slide, yeah, a few times, but still I make mistakes. The pet sample test. Okay, right. So the step is analyze, compare means again, pet sample test, yeah, and you get this window, yeah, where there is variable 1, variable 2. So you must have the pre-test and the post-test score. Yeah? So you just click test 1, it will automatically go to the first box. You click on test 2, it will automatically goes to box 2. Yeah? If you click test 2 first, it will go to this one and you will be confused with your output. Yeah, so make sure you click the pre-test first and then only the post-test. Okay, then click OK. Simple as that, and you get the output. Yeah, pet sample statistics. You got 3 output. Yeah, this is pair 1, meaning the pair that you are comparing between pre-test and post-test. Yeah, test 1 is pre, test 2 is post, and you are excited because your pre-test 62 is lower than your post-test 70. Oh, there is an increase. Yeah, right. But is it significant? Is it significant? What is the answer?
No,
No. Why no?
above 0.05.
Right. Yeah. Good student.
With
Yes.
Falsey.
Yes, the 8 difference, yeah, the 8 points difference between 62 and 70, you think is a significant increase, but statistically it is not because the p-value is larger than 0.05. Yeah, so you cannot say that your intervention, whatever class, talk, or whatever, have improved students' performance. Yeah? Then again, don't be too sad for too long. Yeah? You just find reasons for why you think students have not improved after giving the treatment. Yeah, there are many reasons you can find. Okay, so that is your conclusion. Yeah, if it's significant, then you can say your treatment is effective. If it's not significant, then you will have to say that your treatment have not improved students' performance. Okay, done. Yeah. So this is how you copy paste all the 3 tables and then you write the description. Okay, right. Cross tab weekly. Yeah, this is when you want to find relationship. Yeah. Uh, Another word for that is association between two variables that is nominal and ordinal. Yeah, remember when I say you want to find between class A, B, C, that is nominal, and level of performance, you want to say between groups of weak, moderate, and good students. Yeah, so all these are categorical. So when you want to find relationship, you have to use chi-square. Yeah, basically it's frequency and you cross tab. Cross tab means it's cross tab. Yeah, so the table will look like this. Cross tabulation, and the step is analyze, descriptive. Take this one, cross tabs. Yeah, for cross tabulation. Yeah, and this table will appear. Okay, and you will have one row and one column. So row is here, column is here lah. Yeah, so this is column. You can exchange it. Yeah, it's not too it is not wrong. Okay, so just put one variable into your row. So this is level of performance, and another. Anybody want to ask question? Okay, and another variable into column. Yeah, and then okay, click on the cell display. Just now, click on cells. This window will appear, and you click observe expected. Yeah, and percentages, you click total. Okay, sorry I have to rush, but just follow the click. Okay, continue, and then you go to statistics. Yeah, just now cells. Yeah, now go to statistics. This window will appear, and you click on chi-square. Yeah, so this is the statistics for higher level and continue. So when you are done the analysis, this will come out. Yeah, this is called the cross tabulation just now. Yeah, class row. Yeah, row. This is row Intan, Berlian, Zamrud. This is level of performance column weak, average, high. Yeah. And then it will say how many. Count refers to frequency lah, yeah. 0 people from Intan is under weak category. Most people in Intan 20 is high category. Compared to Zamrud, only 2 people in high category, many more people in weak category. So as expected, right? Yeah. So this is the count, yeah, and this is the percentage, right? So cross tab will chi-square will compare the observations in this cells So this is called cells, yeah. Is there any significant observation among the cells? Yeah? So you just go to the next table, chi-square test, and you need to look at the first line here. Okay, what is the chi-square value? The symbol is like this. Yeah, chi-square. Okay, 54.8, degree of freedom 4, and the significance is 0.000. Yeah? So as long as the significance is less than 0.00, this means there is a significant relationship between classes and performance in genetic, and you can say which one has higher and lower level of weak, average, and good students based on the observations in the cell. Okay, right. Two more. I promise you, two more. Yeah. Second last is Pearson correlation. This is a relationship also. This is a relationship, yeah, chi-square. This is a relationship most commonly used when you talk about correlations, yeah. To find if there is any significant relationship between motivation and performance when both variables on interval and ratio data, then you can use Pearson correlation. Yeah? For example, this is your conceptual framework, motivation. Remember the two arrow, yeah? Motivation, is it related to performance? And motivation, you have 5 Likert scale items. And performance, you have test score. Yeah? So both are one ratio data. And the 5 Likert scale, as I said, you total mean score, yeah, which you will use compute to get the total mean score. Then only you conduct your Pearson correlation. So let me show you quickly how to compute your data. Yeah. Compute ni is simply your calculator, yeah, in SPSS. So you don't need to manually calculate question 1 plus question 2, question 3. You just tell the SPSS how to do it. Yeah. So for compute, you use this step. Yeah. Transform. So it's beside analyzer. Transform, compute variable, and then you get this window. This is the so-called calculator. Yeah. Okay, calculator is where you put your numbers here, but before that, you type in your new name variable. Yeah. So I will type in motivation, anything that is not listed here. Okay. Type a new name, motivation, and then you click on each variable here that you want to calculate. So for example, our variable is Q for A, Q for B, plus C, plus D, plus E, right? So you click here and you click the arrow and it will go here. And then you click on the plus, and then click Q for B, click arrow, it will go here. Put in the plus, yeah, again, Q for C, and so on until you have all your 5. 1, 2, 3, 4, 5. That's why you are dividing it. This is the slash, dividing it by 5 items. And you get your mean score. Yeah, total mean or average. Okay. So you click OK. What you get is this one. Okay. So look at your variable view. Every respondents will have their own score of motivation. Yeah, quickly computed for you. Imagine if you want to compute for everybody's, you will not be able to do it. Yeah, you can lie, yeah, but very tedious. So let the computer do it. You get your motivation score. Now you can do correlation between motivation and test score. Yeah, so this is Pearson correlation. The step is analyze, correlate. Yeah, just now we do a lot of descriptive, and then compare means, right? And now go for the correlate. Yeah, correlate and take bivariate. Bi for two. Two variables. Then you get this table, this output, this window. Sorry. Yeah, and you just throw in the two variables that you want to correlate. So in this case, you have the new motivation variable and the test score that you want to find relationship. Okay, correlation coefficients, Pearson is already take. Yeah, two-tailed. Yeah, if you have open hypothesis, there is significant or not significant correlation, yeah, between one and the other, and you ask the computer to flag significant correlations. This is all already clicked. You don't need to change it. Click OK, and you get this output. Yeah. So you have output. Let's see. Okay, so let's learn how to read the Pearson correlation output. Okay, again, you need two things, two numbers to read. Yeah, one is this is the table will come out like this. Yeah, but it's a repeated table. Yeah, so motivation plus motivation is 1. So you don't need this box. Yeah, motivation correlate with test 2. Yes, you need this box. Yeah, test 2 correlate with motivation. It is the same box here actually. So actually you just need to read one box only. Yeah, one box only because the numbers are the same. So the numbers are Pearson correlation value, yeah, which is 0.135, and the significant, so that is number 1, and the significant value 0.272. Okay. Now there are 3 things you want to read from the Pearson correlation output. Yeah. Number 1 is the Pearson value. Now, the Pearson value, there are 2 things to read. Yeah. Pearson value here, for example, is 0.135. What does that mean? Yeah. 1 is the strength of relationship. Okay. Now, correlation runs from 0 to 1. The numbers, the value. Yeah. Anything above 0.8 is strong correlation. Okay. Oh, sorry, here. Here you got the range here. Anything above 0.7, yeah. You get the guideline from your citation, yeah. Some books say 0.8, some books say 0.7. Just follow your citation. Strong relationship. Anything below 0.5, it's weak relationship. And anything in between 0.5 and 0.7 is moderate relationship. So if it's 0.135, what is the answer? Weak, moderate, or strong? Somebody?
Strong. Strong.
Fail lah tu. 0.13.
0.13.
Range ni.
Weak.
Weak.
Weak, yeah. 0.13, yeah. So between 0.0 to 0.4, so 0.1, yeah. This about because you say the word 0 in front to it becomes confusing. I understand, yeah. So 0.13 is weak. Yeah? Okay. Let me test you. If I get Pearson correlation, the symbol is small r, yeah. 0.63. Weak, moderate, or strong?
Moderate.
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 Better. 0.91.
Strong.
Strong.
Strong, okay, and so on, yeah. So that is the strength of relationship. Okay, good. I consider you pass. Second one is you need to read the sign before Pearson value R. Yeah. So the sign that appears before the value indicates direction of relationship. Okay, what do you mean by direction? Direction can be positive or negative relationship, meaning positive is you have variable X and variable Y, right? Motivation and performance, for example. So your positive relationship, you are saying as X increases, Y also increases. Yeah? Or vice versa, as X decreases, Y also decreases. So both have the same direction. That is called positive relationship. Okay. If X and Y, one increases, the other decreases, that is called negative or inverse relationship. Inverse is better understood. Inverse, one goes up, the other goes down. But the layman term is negative relationship. Okay. What, for example, two variables, as one increases, the other decreases. Example age. As age increases, what decreases? As your age increases, what tend to decrease?
Your
Health.
beauty.
Level of health. Health. Your health.
Energy.
Health, energy, physical ability, yeah. You get it, yeah. So these are examples of negative relationship in life, yeah. Positive, as motivation increases, performance increases, or vice versa. As motivation decreases, performance also decreases, yeah. So you want to see the direction of relationship. Where do you see it? In front of the numbers. Yeah, in the output, yeah, you see here, there is no sign. So if there is no sign, that means actually there is a plus here, but it does not appear. Yeah. So the plus refers to positive relationship. So you can say that there is a positive relationship as motivation increases, test performance also increases. Okay. But if a negative relationship, yeah, the negative will appear here, negative 0.288, yeah, in the printout. Then you can say as motivation increases, performance decreases. And then you will pening lah, headache, yeah. How come lah, yeah, when motivation increases, test decreases, then maybe something wrong, not expected as expected in your hypothesis. Then you need to find out first, maybe you have key in data wrongly, yeah, or your questionnaire items have not been recoded from positive to negative items. There might be something wrong in the way you key in your data if the output is not expected. All right. So now here you have positive, sorry, here positive. So here is positive weak relationship. Right? Yeah, what about here? And anybody can interpret for me? These numbers? Positive or negative relationship?
Positive.
Positive. Weak, moderate or strong?
Weak.
Weak, right? Yeah, so same, yeah, weak, positive relationship. Because you want to put this in your write-up, yeah? Okay. So there is two interpretation. One, the strength of relationship. The other one is direction of relationship. See? So the next interpretation, whether it is significant or not. Yeah. So significant, just look at the significant to tail. Yeah. significant to tail here 0.272, here 0.017. Okay, 0.272 significant or not?
Not significant.
Pandai, yeah, not significant, yeah. Big number 2. What about 0.017?
Significant.
Significance.
Right, yes, significant. So there you have your result. Yeah? This one with test 2, this one with test 1, yeah? Okay, so with test 2, there is no significant relationship. Actually, the result is just there. There is no significant relationship, full stop. You don't need to talk anymore about whether it's positive or weak. There is no value there. When you have no significant relationship, full stop. Try, yeah, but no significant relationship. But if you have significant relationship, okay, you have something more to say. There is a significant positive and weak relationship between motivation and test 1. Yeah? So you can describe more and your result will be something like this. Right up. Yeah. Now see, when it is not significant, it is a short write up, meaning there is no significant relationship between two variables after the motivation talk. Full stop. Do not tell it's positive ke, it's weak ke, no use. Yeah, no relationship meaning no relationship. But if there is a significant relationship with this one tadi, yeah, then you can explain a little bit more. As motivation increases, performance also increases. Okay, so that is correlation. Finally, after correlation, if you want to go a step further, excuse me, you can do a little bit higher statistic from just simply saying correlation. You can say whether X predict Y. Yeah, remember the regression. So instead of just saying motivation relates to test, which one predict, which one you do not know with correlation, but with prediction, yeah, you will have that one head arrow. Motivation can predict test, or can motivation predict test, and you can use simple regression if you have 1-to-1. Multiple regression if you have maybe here, yeah, motivation and anxiety, you have two variables. Yeah? So you can have two arrows here. All right. Now, if you want to predict, then you use regression. It is based on correlation. Yeah? Also, that is why I often joke that regression is the big sister to Pearson correlation. So what is the step? Simple regression, yeah. Analyze, regression. Just now correlation, right? This one, regression. There are actually many types of regression. Yeah, God knows. We will just take linear regression. Yeah, undergraduate linear is enough. Yeah, bonus already. If you can do regression, to me, it's very good. Yeah. Then you get this window, okay, where you have dependent variable and independent variable. So be careful where you put your motivation and where you put your performance. I think I have wrongly do this, yeah. Okay. Because my framework is motivation, influence, test, right? So this should be independent. This should be dependent. So my dependent here should be test. Sorry, yeah, test should be here. And independent should be the motivation. Yeah. So this one you be careful which goes to which. All right. Then you click for simple regression. You can just click OK. Yeah, and you get this output. Simple one. I will just teach you simple regression. Yeah. So you will get these three tables. So you need to interpret all these three tables slightly different. Yeah. So the first table is called model summary. You have two values, important values here. One is R, capital R, and another one is R squared. Okay. So capital R is basically the Pearson correlation. See, 0.288. Yeah, the same. The output is correct. Yeah, my example here is not correct, but the output is correct. 0.288 sama tak? Same, yeah? Same with this one. So it's basically regression using correlation. So it must be the same. Yeah, if it's not the same, something is wrong. So the relationship is 0.288. Okay, and then the R square is 0.083. What is R square? Or the symbol is R square, if you can write that. Yeah. It is the variance in test that can be explained by motivation. Okay, so how do you read this? Yeah, your numbers ni, you just time with 100. Yeah, so you get 8.3%. Yeah, ataupun you say you move the 0 to 2 decimal points, you get 8.3%. Yeah? So meaning 8.3% variance in test ataupun or happening in performance can be explained by motivation. 8.3% only. Where is the rest? 91.7, betul tak? Daripada 100 kan? Where is the other 91.7? What can explain motivation? What can explain performance? Okay, motivation 8.3. What are other factors explaining performance, guys? Anybody? What other factors can predict performance in tests?
Study.
Sorry? I tak dengar. Cepatlah, dah nak habis dah ni. What else can predict performance besides motivation?
Amount of practice.
Okay, practice lagi.
Genetics.
Anxiety.
Wow, genetics, okay. Anxiety level, correct? Interest?
Enthusiasm.
Yes, enthusiasm. Yeah. And so on. So meaning the rest and many more factors in it, this explain the other 91.7% that is not investigated by me. Yeah, I only investigate in my study motivation. Yeah, so 8.3% actually is quite small. Yeah, quite small result. We are not too happy, but that is the result. Yeah, a good percentage would be like more than 30%. Yeah, that is good for social science. Yeah, but tapi for medical, for example, you want a big percentage lah, yeah, to predict something. So, okay, yeah, boleh faham ni, yeah. That is called the variance. How much variance of Y is explained by X. So you just change, yeah, your name for Y and X. Okay. Then that is table 1. Then table 2, it is called the ANOVA table because it is based on ANOVA test just now. Yeah. where the question here is whether the independent variable can significantly predict dependent variable. Yeah. Again, you get the three numbers: degree of freedom, ANOVA value, and significant test. Just look at the significant test. Is it smaller or larger than 0.05? It's smaller. Yeah. So it is significant. So therefore, your answer is yes. Yeah. Motivation can significantly predict. Yeah. So motivation can significantly predict performance, even though it's only by small percentage, 8.3%. Yeah. Finally, if you want to appear pandai, you can write the regression equation. Yeah. Y equals to A plus BX. Yeah. Y is the independent variable, so your performance. A is here, yeah. You just plug in the numbers, yeah. So this is A for constant, and this is B for your motivation beta, okay, and X is your DV motivation. Yeah? So when you write the equation, it becomes test 1 equals to 31.06 plus 8.421. You take the numbers from here, yeah. In bracket, just write motivation. Yeah. And this needs another explanation, which I will not go here. Yeah. You can read on your own, and I have given you example here of how to write your analysis for regression. Okay. All right, I am done. I have the qualitative analysis, but I think somehow I just remembered that last semester we had another session for just qualitative analysis. Yeah. So is Dr. Farhana still here? If we can.
Yes.
Yeah. We forgot to plan whether this session will be conducted separately.
Yes, I think we have to do this separately, maybe in 2 weeks' time, because next week is your holiday, kan, and cuti sekolah. So we will do the following week for
Another session. Okay, that's good. Yeah, that saved me because actually I am not good in the qualitative part. Yeah, I am a quantitative person, but not expert juga. Yeah, just a little lah. So, but I am I am quite confident of helping you with your analysis for the basic analysis. If I can answer you, I will. If not, I will say, okay, I can refer you to somebody else. Yeah. So I am done. If you have any pressing question you want to ask, or is there any question in the chat box?
Hi, can I ask one question? Assalamu alaikum, Dr. Sharifa. Although,
Hi, Shazia.
how are you?
Fine, thank you.
I was listening your analysis of chapter 4 of your quantitative, although it was going from the top of my head because I'm a totally qualitative person,
Yes.
but it was very interesting. And just one quick question, since I'm writing chapter 4 these days, and I have started writing the themes. There are 3 questions, as you know, in my research. Just wanted to ask you that, like the findings, for example, let's say the first theme is related to the bullying of the students with the towards the students with learning disabilities. So I have taken each student separately, like there are 5 students, each with a specific disability, and have explained, like I've written what they said in an interview. And so after writing all this is the things which I have written are the findings. Okay. Chapter
Mhm.
4 deals with the findings and the results. And chapter 5 deals with the discussion. So I just want to know, okay, that silver lining between these two chapters, that in, for example, if I have written one theme, should I have to give my views there and then, or I should be keeping those views for chapter 5? That's a question. Like, I am not sure what to do.
Okay. All right. Quickly, yeah, I forgot that I have my chapter 5 here, in short, yeah. So, basically, when you have written all your chapter 4, yeah, using the
Yes.
template that I gave earlier, your chapter
Mm-hmm.
5 is first with introduction, a short paragraph, and then you
Mm-hmm.
give your summary of findings,
Mm-hmm.
uh, follow answering each research question. Yeah, so this is
Mm-hmm.
where you say you have your themes, right? Yeah, you
Mm-hmm.
have your transcription written here. Yeah, who says what here? Yeah, and with 5.4 is where you discuss further what you find in your findings. So whatever you want to say just now, you put under discussion.
So
Elaborate.
basically, chapter 4 is going to be just the findings of what those students have said during the interview, and their, I have pasted their clips as well, like whatever they said. For example,
Yeah.
if somebody
Mm.
has said that, okay, bullying has been one of the major causes for their delay, for not performing well in the class, and
Mhm.
then in the next line I have written whatever he has said in inverted commas. So that's what chapter 4 is
Yeah,
all about.
that's
Or
basically, but it's not like just pasting one after another transcriptions, right? Right. You can insert your short observation or your short interpretation
yeah,
of
yeah, yeah.
this thing. Yeah,
Okay, okay,
between the lines. Yeah, but
okay.
in 5.4, you then give more elaboration, and then you can compare and contrast with the past research. Mm. Yeah.
Okay,
Okay.
okay,
So same
sure.
with you for your undergraduate chapters. Yeah. Chapter 5, same thing. Yeah. A summary of findings is where no more numbers here. Yeah. If you are doing quantitative, no more raw data. If you are doing your qualitative, yeah, you just want to write here. Yeah. So you can copy paste your chapter 4 to chapter 5, and then you delete all the tables and the numbers. Yeah, that is my trick lah. Yeah, you delete all these sections. Yeah, the numbers and the tables. You just leave the sentences, and then you replace and you paraphrase your sentences, and then you get your interpretation elaborated, and then you do your discussion here where you compare with past studies, and then give some implications of the research of the findings to what to the policymakers, yeah, to the teachers, okay, to the parents, maybe implications, right? And then you want to recommend something again to all these three parties, and then you make your conclusion. Don't forget your references and appendices. Okay, Shazia, if you want to ask more question about qualitative,
Yeah,
you have to attend.
yeah.
You have to attend the next session. Yeah.
Okay, just one
Okay.
what you have just written over here, implications and recommendations. So implications is what could be the result, and recommendation. So we have to, if I'm not wrong, in recommendations, we it's going to be the policy towards the policymakers and towards the teachers and the parents, isn't it? So implications is what implications could have, the positive or the
On
negative.
yes, correct. Thank you for correcting that. Yeah, recommendations for the policy and the teachers and parents. Yeah, implications for PhD is on the theory, is on the research. Yeah, and implications of your findings to the field of whatever you are investigating. Yes, correct.
Thank you. Thank you, Dr. Sharifa. It's always been a
Okay,
pleasure. And
welcome.
all those
All
who
the
are
best.
doing quantitative analysis, I think you are the most lucky people to have Dr. Sharifa as your quantitative, sorry.
Okay,
Uh,
all right. Is there any other question from undergraduate students? Don't be shy. Is there anything written in the chat box, Anna?
Just that ada PhD student minta presentation yang chapter 1 to 3 hari tu.
Oh, okay, that one. You can contact me and I can share with you. Yeah, from previous ones. Yeah.
Kejap ada soalan sekejap. Assalamualaikum Doctor, is it okay if we exclude neutral in our Likert scale for the questionnaire?
Okay, there has been a debate, a long life debate lah, yeah, whether you should use 1 to 5 or just 1 to 4 or 1 to 7, yeah. So whatever you choose, you just make sure you cite, refer to whatever past research, yeah, or the expert from the textbook saying that a 5 Likert scale is good or 4 Likert scale is good if you want to do that. But don't just change. For example, if you take from past questionnaire 5 Likert scale, you just transform to 4. Ya, suka-suka. Nanti dia tak no validity there. Yeah, you must have reasons why. But there is no right and wrong answer. But in general, people are using 5 Likert scale here. I know you don't like the middle answer because people tend to, you think, yeah. Sometimes we think that people are lazy and just circle neutral. But sometimes if you think about it, people are thinking about I'm not here and I'm not there. So maybe it is their true answer. Yeah. So yeah, that is not a good answer, but find your citation. Okay.
Alright, ada satu lagi soalan. Is it possible to run the analysis using paired sample t-test if we only have 10 respondents?
Okay. Now that is something about sampling size, yeah, sample size. Now I would say for undergraduate level, it is acceptable, yeah, acceptable lah. We allow, yeah, if you don't really follow the through statistical steps, yeah. Because your level is we want you just to appreciate the research steps and writing of the chapters and so on. So 10 but if you can find the citation that says with paired sample t-test the minimum numbers can be as small as 5 or 10, it would be very good for your writing chapters. Yeah, before you say that your sample is only 10, you can argue why that is okay. And you can just type in Google nowadays, yeah, minimum sample size for paired sample. You will get lots of references. So you find out, yeah, 1 or 2 references that say this study did with only 5 sample and that study did with only 10. So that will support your allowing only 10 sample. I think you can do it. Yeah? Cuma if possible, you find support for your small number of samples. Okay, right?
Okay, I think ada lagi satu soalan. Nak tanya kalau MANOVA boleh kira correlation ke?
MANOVA, if I'm not mistaken, it's from when you want to compare, when you have, ni I takut ni, tak reti nak cakap, when you have instead of one independent variable to one dependent variable, you have one independent variable to two or more dependent variables. Yeah. So it is not correlation, it is comparison. Yeah. That needs another workshop lah. Yeah. But yeah, you need to read lah with all these statistics and writing. Yeah. There is no like sitting for 2 hours in this workshop, you know everything. Yeah. We take years to understand and become knowledgeable. Yeah. Even then, I won't say that I am knowledgeable in this thing. So I'm saying Manova, I am not too expert, but I know it's when you want to study more than one dependent variable. Okay, and you can get the steps in SPSS again, in Google, yeah. Okay, Hannah.
Right. Rasanya dah tak ada soalan dah kot.
Okay, can I, if not, can I just say thank you very much to everybody. If any of you, especially the undergraduate students, yeah, you are having problems with your analysis or how to analyze something, you can just text me anytime and share with me your data or whatever. I will help you to guide on your analysis. Okay, Master and PhD, also you are welcome. Inshallah, I will try to help. Thank you. Have a nice day.
Thank you.
Hannah.
Thank you everyone for being here. InsyaAllah nanti Dr. Sharifah Muzlia will share the slides with me and I will pass on to the undergraduate students and maybe Dr. Sharifah can send to the postgraduate students.
I have in the chat box earlier, I have I have given the link to the slides.
Okay.
And yeah, and the attendance form. Can you please sign up, guys? Yeah. And later in the same Google Drive, I will upload the recorded session here. Yeah, it will take about 1 or 2 days. Thank you. Yes.
Thank you. Okay everyone, so thank you very much. Kita sudahi dengan surah Wal-As and tasbih kifayah.
Thank you very much. If you want to ask anything personal, you can stay back. I will stay back and wait for you. Thank you, Dr. Farhana.
Thank you. Bye.
Thank you, everybody. All the best.
Thank you, doctors.
Welcome.